Hi, this is Mike Lopez, and in this video we're going to be looking at the repeated form of partial fractions. Let's have a look and see what we mean by the repeated form. Quick example, 6x plus 5 over x plus 3 times itself, so that's the repeated form. Okay, so the x plus 3 in brackets is repeated, obviously, once more here. And what's our normal general solution to try to solve these problems? Well, we start off with a of x plus 3 plus b over x plus 3 all squared. Okay, so again, as in the previous videos, what we'd like to do is to eliminate all these fractions. In that case, it makes a lot of sense to take a hold of this denominator on the bottom left here and multiply everything times that denominator, like so. And that will then give us, we change this to red, so we're then going to have x plus 3 times x plus 3 times what was already there, which was 6x plus 5. It's all sitting over x plus 3 times x plus 3, of course. And I'm saying this is equivalent to a lots of x plus 3, x plus 3, all sitting over what was there in the first place, which was a single x plus 3 over here for the b side, b lots of x plus 3 times x plus 3 sitting over x plus 3 all squared. And we can notice that there's some cancelling out needed here. That bracket cancels with that one, that bracket cancels with that one, and this bracket cancels with that one. These two brackets, when multiplied together, give you x plus 3 all squared, which is what sits on the bottom. So that all goes out. Okay, so if I change colour, go back to blue, what I'm seeing is 6x plus 5 equals a lots of x plus 3 plus b. Okay, pure and simple. I would like to give this little equation a tag. Let's just call it equation 1, because we're going to refer back to this shortly. Okay, back to blue. What's normally in your bag of tricks when you're trying to solve expressions such as this? Well, normally a good idea is to always let the bracket, if you see 1, equal 0. Let's see what happens in this case. Okay, so let me change back to red. So what we're trying to say is, why don't we let that bracket equal naught? Therefore, what's the needed value for x? Well, of course, it's minus 3. Okay, therefore, we can say 6 lots of, so I'm referring to equation 1 now, 6 lots of minus 3 plus 5 equals, well, a lots of minus 3 plus 3 is going to give you 0 lots of a, so that's just 0. So we just have b on the right hand side there. Okay, therefore, tidy up what we have on the left. Got minus 18 plus 5 equals b. Okay, therefore b is minus 13. And again, that's going to be quite useful to us soon. Let's just put a ring around that. Okay, let's scroll down a bit and let's have a look how we can manage to find a value for A. Okay, how are we going to do that? Well, we know that B is 13. Surely we can sub B equals 13 into equation 1, and that will give us a value for A. Let's have a go. Why don't we change back to blue? Okay, so from equation 1, go on. This is what happens. So we can say 6x plus 5 equals A times x plus 3 plus B, which is minus 13. So plus minus 13 is minus 13. Okay, looks like we've got two unknowns here. We would like to find a value for A. Why don't we just let x equal 0? Okay, another common trick. So let x equal 0. That is then going to give us 6 lots of 0 is nothing. Gives us 5 equals 3A minus 13. Okay, therefore A equals, well, that's going to be 5 plus 13 over 3. Okay, which is 18 over 3. Therefore A equals 6. Okay, let's circle that. Okay, so up here we had B equals minus 13, A equals 6. So what are we saying then for our proposed answer? What we're saying is, we start off with the original problem, which was 6x plus 5 sitting over x plus 3, x plus 3. We're saying that's equivalent to A, which is 6. Look at the top here, 6 over x plus 3 plus B. Well, B is minus 13, so we can put a minus in here. 13 over x plus 3 all squared. Okay, now there is a way, of course, to check these answers, or these proposed answers. So is that correct? Let's find out. Let's do a quick check. What I'm going to do on the check is I'm going to say 6 over x plus 3 minus 13 over x plus 3 all squared is the same as writing, and let's put the common denominator in. Here you can see two fractions, two denominators. The common denominator is x plus 3 all squared, which is the same as x plus 3 times x plus 3. Okay, we look at the first one, x plus 3, put it brackets if you wish, goes into this common denominator, x plus 3 times. Multiply that result by 6. So we have 6 lots of x plus 3. Similarly for this denominator, that goes into the common denominator once. So minus 13 times 1. We evaluate this lot and we have on the top 6x plus 18 minus 13 over x plus 3 all squared, which is the same as writing, well, 18 take away 13 is 5, so we've got 6x plus 5 over x plus 3 all squared can also be written like this. And hey presto, looks like we have reverse engineered our answer back to what the original question was. Okay, Thanks for listening, and see you in the next video.